this around. I want to get the angle up so you can see it and it doesn't hit the big reflection. Can you see this?
Now for me, I can see it.
I can see.
I can see it.
Okay. Can you tell me, just when I sit down, is my head cut off on the camera? All good?
No, you still use that.
Okay, cool. Okay. All right, so can I ask... I think it's running. Can you just check at the top?
Yeah, it's running.
Okay. Okay, so first minute or two, just want to take a breath, get into the space, okay? I'm going to play a little bit of music, just clip out one minute or so, just to try and create an ambience. Brandon. Yeah.
Yes, sir.
And then I'm going to make an invocation, right? And then I'll ring the bell, and then we'll have the session. The session will be science, but the session will be science through analogy. So this is what I've learned really actually from this last month, is that teaching science, it goes over most people's heads. So we're just going to try and tease out some scientific truths through analogies. And I think you'll come away from this going, aha, I know the distinction between 1.5 and 2 after this, okay? So the first thing I want to do is I want you just to... No, that's fine. Just want to keep some breeze for the... Okay, so just give me a minute of just hear some music, and then let me speak, and then I'll ring the bell, and then we can come back into the space. My invitation to you in this session is that you regard the environmental sciences, or receiving the environmental sciences, or learning about the environmental sciences. I invite you to consider that this is itself a form of spiritual practice, a part of or a practice associated with eco-spirituality. And in my journey, I've found the understanding of how the Earth system functions according to the scientific research to be extremely valuable in gaining a deeper connection of where I fit into that. Okay, I am the part of nature that communicates the environmental sciences. My name is Guy Lane. I will die one day. I'm not particularly looking forward to that day, but I have no fear of what happens beyond that. And between now and then, part of my role as a part of nature is to share the environmental sciences. This is what I'm trying to do today. Okay, can we all see the screen? Right, now, turn it around. I want you to consider our little ball of Earth floating around in this vast universe. And I want you to consider that all that black stuff on the outside of the humans is really, really, really cold, okay? It's really cold. It's about minus 270 degrees Celsius out there. Really cold, okay? If you were to freeze nitrogen, I think that's minus 130 or something. This is super, super, super cold. In fact, the scientists talk about this concept called absolute zero, which is where you can't get any colder, and that's around minus 273. So space is just about on the edge of as cold as it can get. Okay? And I want you to imagine that this little ball that is floating around in space has the benefit of a neighboring body called the sun, which is this massive ball of gas, which is so dense that it's driving a process called nuclear fusion. And that nuclear fusion is throwing off these vast amounts of shortwave radiation that we know as sunshine, as sunlight. And I want you to imagine that if you were to go outside on a cold day and stand there and wait for the cloud to pass And in that moment that the cloud passes and you feel the sunshine touch your face, it has travelled 150 million kilometres or so to reach you in a form that when it touches your skin turns into warmth. And you feel that warmth. And so the shortwave radiation comes across space, touches a surface, whether that be your face or the rooftop or the street or the house or whatever it is, and it turns that energy into a different form, which we then refer to as long-wave radiation. You feel that as warmth on your skin, and then your skin actually starts to radiate out some of that energy in the form of long wave, in the form of heat. Okay? And this is exactly the process that has taken place on Earth, that the Earth is drifting around in space, illuminated by the rays coming from the sun. It's turning that shortwave radiation into warmth, and that warmth is radiating back into space. But what's happening is a proportion of that energy is being retained within the Earth system, and in particular by, or it's been distributed or accelerated, if you like, by the greenhouse gases. And so that the planet has absorbed a certain amount of heat over time. And what the living systems on Earth have done, and this is Gaia theory, is that the living systems of Earth have, over the last 3 or so billion years, have maintained conditions so that the right amount of energy is being radiated out and the right amount of energy is being kept in to keep the temperatures within a narrow range, which is exactly the way that life likes it. Okay, so that process is basically creating a situation where our planet, okay, drifting around in space, minus 270 degrees Celsius, is actually kind of warm, okay? It's warm. And that warmth, if you were to actually look at that, at the planet, whilst we talk about this average temperatures, and the average temperature of the Earth, the way it really ought to be, is around 13.9 Celsius, but let's just call that 14 from now on, just to keep it simple. But that is an average temperature. If you imagine if you had a thermometer parked every square kilometre and measured it up, this is an average temperature. So the middle part of the Earth, the equator, is warmer. I think it's around 30 Celsius on the graph here. And then the northern parts, the polar parts, are colder. Okay? And what the scientists do when they're talking about the Earth system, they create this average. So in reality, an average is a concept that we use to help explain things. The tropics are warmer because the sun hits the Earth at a higher angle of incidence, so at 90 degrees, and they're also like a much larger target area, if you like. And then the polar regions at the top of the Earth, the sun comes in at a much shallower angle, so it delivers less energy, and there's actually a smaller area. So you get this planet which is cold at the poles, warm in the middle, on average 13.9. All right? That's the temperature that the planet likes it. Now, in 2018, a science paper came out with the long technical name, Trajectories of the Earth System in the Anthropocene. I personally love saying that. I understand that it's convoluted, but what they're basically saying, trajectories of the Earth system, they're saying heat pathways in the coming years. This is really what it's talking about. And what the paper did was it looked back at all of the records of life on Earth over billions of years, and what they saw was that the Earth seemed to actually sort of fit between either a warm phase or a cold phase, and that in between it kind of wasn't stable and it flipped one way or the other. Okay, and what they're saying is that if you look at our temperatures today, the 13.9, the 14, that if you go above somewhere between 1 and 2 Celsius, it triggers the Earth to go into this hot phase. It's referred to as the hot house. Okay, and the diagram that came out of this paper is here, and I don't want you to get caught on the detail, but I just want you to consider that the blue loop at the bottom represents the last 1.2 million years of ice ages. Okay, so we're in the ice age cycle, the planet basically gets cooler by about 5 Celsius, and then all of the ice starts to build up, so cold that when it rains it comes as snow layers on top of each other, and as it keeps raining then the oceans are drained of water to make the ice fields. That this part of the world under an ice age has got about 1 kilometre of ice on it, something like that. That when we saw the caves, the Cro-Magnon people were the people that lived before the last ice age, and they would have had to go away from here, south, because the ice came and it would have been very difficult for them to survive. And as the ice retreated, we call that an interglacial, as the ice retreated, then humans could come back into this part of the world. Okay, so there's this cycle, this is what the lower circle is saying, that there's this cycle that goes over about 100,000 years. You go into the depths of the Ice Age, and then it gets warm again, and then it goes down into the depths of the Ice Age, and that's a cycle that's been going on for over 1 million years. What the graph shows is that we have departed that cycle because we've added all of this heat-trapping gas to the atmosphere. And the line that basically comes up here is showing that here is Earth sort of around about now in terms of like the temperatures. So if you imagine that the bottom of the loop is the cold temperatures, Ice Age, and the top is the interglacial warm period, we've gone beyond the warm period, okay? And what the science paper is basically saying is that when you get more than a couple of degrees above the temperature where it should be, all of these natural processes kick in that make it go zoom all the way up to this really hot phase, okay? The hot house, all right? Okay, so just to put some numbers to it, so if we go cooler than we are by 5 degrees, we get a kilometre of ice over Bergerac, okay? And if we go up to, say, 8 degrees above where we are, that kills off most life on Earth. That's the hot house. And the diagram at the top shows a representation of what's called the Permian extinction. So over the last several billion years, there's been 5 mass extinction events where most of the living things on Earth basically just collapsed and disappeared, mainly because of climatic reasons, big changes in the climate. The last of the major extinction events was the dinosaurs getting taken out, and that's broadly believed to be something to do with an asteroid that came in, smashed the ground, put all the dirt up in the atmosphere, killed off photosynthesis, knocked off the big dinosaurs, but created the space for the mammals to come and become range superior. 5 mass extinction events. The one that nearly took out nearly everything, is called the Permian extinction, and that was 270 million years ago, and that was triggered by, if you like, a whole series of volcanic eruptions in the northern part of the world, up in the Deccan Traps area, up in Siberia, and this huge expanse of lava spread over coal fields and peat fields released huge amounts of greenhouse gas, carbon dioxide predominantly, into the atmosphere. The planet got hotter, the atmosphere got hotter, the oceans got hotter, the oceans stratified, they lost their oxygen. You got this growth of these organisms that produce sulfurous gases, and most of what lived in the ocean died off, and most of what lived on the land died off as well. Now that's what happens when you go up to 8 Celsius, okay? That kills off. Now there's no way that humans can survive that. We can't even survive the journey there, okay? So that just gives you a bit of a sense that the temperature of the planet is kind of important, and that it ripples and wobbles around this sort of relatively, it's not like 60 degrees this way and 40 degrees that way, it's okay. It's like 4 below gives you an ice ball, maybe 6 or 7 below gives you the whole planet is basically turned into ice. Okay, so this is a narrow range, okay? That's the important part of this conversation. And so where I'll leave that for a second, where this concept of the 1.5 versus the 2 comes in is that since around about the mid-80s, scientists, or more importantly politicians, have used 2 degrees above the baseline temperature. Remember we were talking about how the planet should be around 14, that's where it should be. So the term that they use is 2 degrees above the pre-industrial baseline, right? Pre-industrial, the term is not properly defined, and there's wriggle room, it makes it a bit confusing. I won't go into it, except to say that most of the warming that we've seen by humans has happened since we've been burning coal, which is associated with the Industrial Revolution. So they're saying whatever the temperatures were on the planet before the Industrial Revolution, that's our frame of reference. We call that the baseline. So when we're talking about 1.5 or 2, we're talking about 1.5 or 2 on top of the temperatures back then, all right? And what I've shown you is that if you were to go 4 backwards, you've got an ice age, and 8 forwards, you've got an extinction of most life on Earth. The point about 2 degrees, though, 2 degrees above baseline, is that what is regarded, as per the diagram I showed with the loop on it, is that when you get to 2, there's all of these natural feedbacks kick in, and that goes beyond the capacity of the humans to actually regulate it. If you think about climate change as the problem of too much greenhouse gas going in the atmosphere, at the moment we're the ones that are making the problem. So theoretically we're the ones who can actually fix it. But when nature starts making the problem, it sort of falls out of our hands. And what those feedback loops are, positive feedback, reinforcing feedback loops are, for example, when it gets too hot, the forests start to burn, and when the forest burns, they release greenhouse gas, which makes it hotter still. As it gets warmer, the ice in the Arctic shrinks, and that ice in the Arctic has got an important role in reflecting sunlight away. So as the ice shrinks, you get more of the sunlight comes into the ocean, Arctic Ocean, which makes the ocean hotter, which makes the ice shrink. And there's a whole suite, there's dozens of these negative feedbacks. There are also positive feedbacks as well, those are the positive feedbacks which exacerbate the problem. There are also negative feedbacks which ameliorate the problem, but there are more positive feedbacks than negative. So if we go past 2, we're in big trouble because it potentially slides away from us. So again, what I wanted to do is to try and create that in terms of analogy, and I'm not going to try and list, I've got a list of all of the different, distinctions according to the climate models of, if it's 2 degrees, you get this much extreme weather, and if it's 1.5, you get this much extreme weather. There's plenty of that data that you can go and look at. But what I want to do, just by way of analogy, is to create the analogy of a swimming pool with a shallow end and a deep end, okay? So you can still drown in the shallow end, and so think of 1.5 as the shallow end. Okay, you can still drown in the shallow end. 1.5 is already going to mess things up. We're going to lose most of the coral reefs of the world under 1.5. Okay, but the thing is about the shallow end is that it's counterbalanced by the deep end, which is where it gets really dangerous, where there's no coral reefs on the Earth. Okay, but that analogy isn't quite sort of strong enough, because really what there is at the deep end is one of those really deep holes that goes all the way down where everything's lost. That's sort of a way of understanding it. And what the 1.5 and where the 1.5 paper came from, or the concept came from, was that everybody since the mid-80s has been talking about 2 degrees, which is kind of like the edge of the cliff, right? So it's all like, hey, the target is the edge of the cliff. So let's use a cliff analogy, all right? So if you're really concerned about climate change destroying your civilization, okay, then you want to be over here somewhere. Okay, here's the White Cliffs of Dover. Yeah, and here's like the big grassy area where you can go and sit and check it out. Okay, if you're really concerned about climate change destroying your civilization, you wouldn't go anywhere near the cliff, all right? But as we get closer to the cliff, we've got these people here on the track. It's 1.1 degrees Celsius. We're about 1.2 above baseline now, but that depends on what your baseline is, right? And there's wibbly wobbly room, so we might be 1.4 or we might be 1. It's around there, okay? The variability in that pre-industrial baseline concept is about 0.2 of a degrees. So where we are now is really kind of like where these people are, and they're on the beaten track. And theoretically, we can get by without most of the coral reefs. But if we keep going, you get closer to the edge, and then when you get to 2, you're effectively sitting on the edge. That's the concept, and this is the insanity of 2 degrees as a target. It's like, imagine you go down, you park your car and your kid runs out of the car and you shout to the kid, stop at the edge, right? You don't have any room for error. And also the way that they've framed the whole carbon budgets in the 2 degrees, we've only got a 66% chance of not going beyond 2 degrees. So it's not 90% or 95% or 99%, right? So the 2 degree target is a form of collective insanity, and yet that's the target we got. So somebody pointed that out at one point, and somebody said, yeah, actually, I see your point. That's actually really good. It was actually, I think, the island nation states made this big statement and lobbied that there should be this other target, which is the 1.5. And this big study was done to sort of understand the difference, and there was a big difference in terms of the biological systems on Earth, like catastrophically damaged under 2, but, broadly survive under 1.5. And so this is why we had that little ceremony the other day. Was some of the most contemporary science is basically saying that if you look at what we've got to do to prevent the temperatures going to 1.5, we don't have an answer for that anymore. We look at the way that societies change, the way that politics change, the rollout of new technologies. We don't see a pathway to stop before 1.5. And that's why we had the little ceremony the other day to say that we've left the shallow end, okay? We're heading towards the deep end, all right? And so that's the sort of broadly the context. Now, of course, whilst 1.5 might be out of reach, maybe it gets to 1.6 and we find that we slow it down, and then we start to bring it back again by drawing all that excess CO2 out of the atmosphere. Okay, so just because 1.5 now seems out of reach doesn't mean we're automatically going to 2 and off the cliff. And that's important stuff, okay? But what it's basically saying is that the world leaders have basically pushed us out of the shallow end and we're now heading towards the deep end. And that's really the sort of takeaway of it. And what we need to do, if we actually want to get through this Anthropocene crisis and get through the other side of that with enough intact ecosystems and societies, and that we can actually then re-establish a new form of civilization that is wise to these things, then conceivably we could be living on this planet happily for hundreds of millions of years. That's a very grand vision to hold. Right? Okay, that's what I wanted to say. Anybody had something they'd like to share?
Very good.
Something to share from the heart or the head? It's heavy stuff. Big stuff that most people don't get the opportunity to sit with.
Thank you. I recognize what you're saying, like the insanity and still it's 1.5 degree, it's 2 degree, it doesn't reach me, it's degree, it's numbers, it's figures.
Yeah.
And I always have the same problem, I came and I was like, okay, so I will have image of what does it mean.
Yeah.
Otherwise, it's figures for me.
Yeah, and this is.
I understand that what you're sharing seems to be very important for the people who talk about climate. So it seems to me that it's really important, to talk about the transition people, environmentalists, people like me. It doesn't. It's numbers.
Ah, okay.
Okay.
Yeah.
Sorry, please, you first.
No, you.
I think it's a great presentation and great analogies as well. I get what you're saying.
Yeah.
It means the Western world to the rest of the world is a very different. I think a map of the world showing all the places that would be under at different degrees would be really effective, and that will log migration, death.
Yeah. Yeah.
So, but also there's a risk there in my head actually. If I'm sat in my armchair in London, that I'm all right, Jack, until it hits 2.5 degrees. So depending on your audience, I don't know, but I think it's very effective. But it means a lot of different things to different people.
Mm-hmm. And just to your point, Valerie, thank you, Brandon. I hear you, and so allow me to make another analogy, okay? And then this is this kind of scary stuff, is that what is happening as we're going through 1.5 and towards 2 is risk is getting greater. And the risk is getting greater that when you go to the market, there's no food there, right? And that there's street fights, right? At 2 degrees, there's just blood on the ground, right? That's all that's available at the market stall. And at 1.5, your normal 25 vegetables is now brought down to 10 vegetables. So there's, okay? And if we go back, if we can wind it back, then you've got all your vegetables back, okay? At 1 degree, we're still kind of holding on, the vegetables are coming in. 1.5, you're losing the diversity of your food. 2 degrees, it's just a shit fight.
That would be incredible graphic.
I think it's very, very, very powerful to go toward that direction. I will go even deeper because we're selfish, so that the ocean is dying, we don't click. Like the market, okay, we're in 2022, you have 2024, 2025, with the parallel of the degree, people see, then the price, okay, you still have that, but price, you have one pack of one bread, €1, €2, €3, €4.
Yeah. Yeah.
This will
Yeah.
speak to people, this will speak
Yeah.
to me,
Yeah.
and also this will help me to make realize people that they need to care about food.
Yeah. Yeah. No, that's good.
Everybody is talking about environment, they don't realize what you're
Sure.
saying.
That's a great
Yeah.
point.
Yeah.
We don't have to look into the future to see that.
No?
COVID, Ukraine, I think there's some good present day examples of where people are fighting in supermarkets for freaking toilet roll in the UK.
Yeah, or just occasional like a flood or like hurricane triggers that stuff.
Yeah, so I
It's
think
like-
it would be a really nice graphic to show, and you can have real day examples. 1.5 degrees is Ukraine grain crisis times 10.
yeah, sure.
No, I hear you. I really loved it, and I like this picture also. It's very graphic. Yeah, I think for sure there's many examples, no, of things that will start to tip over or disappear when. So you just took the example for the coral reefs above 1.5, we can say goodbye to them. Because unless we find out the technical solution, you know, this is so for a moment to take and to think about what the coral reef, and then even beyond that, we think it's just a coral reef, but it's the food for the ocean.
Yeah,
It's the
millions of people.
so it's not just the coral reef, but the impact it's going to have on the whole of the sea, and thus on the whole of the land, and of the. So it's like you can make like a whole graphic on the wall with all these little pictures that are actually cascading when we go into the. You know, like it's all connected. I think the food one is really good because it's really close
Yeah,
to home,
and
no?
there's everyone. Yeah.
But maybe you need more pictures that are really, you know. Although I'm also worried if you go too much into graphic or too painful, then it becomes also I can't watch it.
Yeah.
Actually, the food one's a great one because people can start growing food at home and start preparing now, which means that will create change immediately for the better. So there's a domino effect.
Because what we're talking about, actually I don't know in other countries, but I don't think it was invented in France, it's like les fresques du climat, the climate fresque, and it's all over everywhere in any now festivals or whatever. You know what I mean? Les fresques, maybe it's French. It's exactly what you're describing. Fresque is kind of a painting.
Oh, fresco.
It's exactly what they do. Like you go on the stand and they have pictures and like with I don't know, like pesticide, 1.5 degree in the ocean, and that they interact with people and to okay, what do you think? And people guess, and then they open the thing. It's like tuck, and then people can see all the connection. I will check if it's English because it's really efficient and it's like kids love it because it's kind of a game.
it's very visual.
Yeah, so that's done.
And so is this just at a festival, or is it painted on a building? Is it a big piece of
No,
wood?
it's like a game. It's a game like usually in kind of a festival, or sometimes they do it in schools or you know, things like that. Market sometimes.
So it's like a big picture?
No, it's exactly. It's a draw, and they have photography, and there is you know, it's the same thing all the time, and people got trained. They do one, and then you can repeat it, and something like that. So just to say that this is done and it's great, it's working because people realize. But still, and the food, yeah, it's might be more even more powerful because it's your money and your stomach.
Yeah. Yeah.
If you did like apples, you know, long ago there were many varieties of apples. You could take something like that and you would see all the varieties, and then how they narrowed down to now we have a few in the supermarket, and then the price starts going up, and then you don't have any more apples. Yeah,
look, these are really, I think these are really valuable insights, and one of the web pages that I came as I was doing the research just had like it had 2 columns, right? And it was saying things like, you know, the chance of getting washed away in a flood at 1.5 is 30%, and at 2 degrees is 40%, and you know, it's just numbers and numbers and numbers. So, you know, so I think the cliff and the deep water analogy are appropriate, but it's not so personal as something like food, if you're particularly big on food. For me, the food analogy was, I don't know much about food. I always seem to stumble across it when I'm hungry. So it's not so powerful for me. Something like the coral reef really speaks to me, because I've spent time around reefs.
And I'm also realizing that to the degree what you're saying, that it's insane to put as a boundary.
Yeah.
But then if you don't refer to, I'm just thinking, if you don't refer to what actually happens after 2 degrees, then it's still just sort of a concept.
It's a stepping stone on the way.
Because people think, what is 2 degrees?
Yeah.
But if you actually know that we can't return almost anymore, and that what actually starts to happen after the 2 degrees, that I think you can throw in some analogies there as well, because then it's more like, oh, it's not just 2 degrees. Because for me that number seems so small. So
Yeah.
I can imagine that people think, oh, well, what is 2 degrees?
Yeah.
It's a small number.
Then again, I think I feel it's all the difficulties. It took me 5 years to realize who I can contribute to when I do my workshop. And I realized that it was not everybody, it was the cooks.
Right.
And I'm just at the beginning, because it took me so long to realize that. And what I feel is that, for me, what I feel is like this talk is for political people, government people, you know, who are not scientific, who pretend to understand. Actually, they don't really get it, but they have a timeline because they should feel responsible. And this, as a politician, would really speak to me as a city mayor. You know, so it depends who you want to talk to. Is your contribution for people mainstream, or it depends who you can touch around you.
Yeah.
So
Yeah.
I sort of agree but disagree, because politicians need votes, and if their demographic is people of working class community, a shopping trolley going over the edge with food in it will probably hit home really bloody hard to them. Like, what? My constituents can't feed themselves? I'll be lynched.
Yeah.
But in terms of urgency, I'm not even sure that politicians realize this really speaks. And then, and 2 degree means that your citizens won't have food or won't be able to pay. You will have to.
I didn't see this as a finished thing. I think the next slides can actually go into that and have different slides coming in. I think it's a really good presentation. Well done.
Yeah. Okay.
And by doing it in parts like that, you might be able to mitigate the overwhelm.
Yes.
Yeah.
You have to get up and do some somatic work even before you go on to the next part.
Yeah.
That they release and feel.
Yeah.
And I think this would go perfectly fine for high school kids. I'm not saying that maybe it is to be a bit higher up in the classes, like in the older high school kids. But with these graphics, especially also with the water, you know, shallow, still drown, the deeper, and this one, it's like good visuals too.
Yeah.
What impressed me with this is that they're pretending that 2 degrees is okay, and you're right. At the last COP, the Prime Minister of Barbados stood up there and told him 1.5 or we die, and they go, okay.
Yeah.
But with this one, you see that's what's going to happen. This was a good graphic for me to be able to say to people, well, look at it this way. At where we are now, we're a little ways from the edge. At 1.5, we're getting pretty close, and we've got to worry. But at 2,
that's
no
right.
coming back.
That's right. And again, the carbon budgets is, they say if we burn only another 600 billion tons of carbon over the next 20 years, that will get us to 2. That will give us a 66% chance of not going over 2. It's like insane. It's not even like everything about 2 degrees. And the way it's conceived and the way it's been packaged, it's like, here you go, and you go, oh, okay, and you look at the detail and you go, what? Two's insane,
You know,
according to the science, right?
we're talking about politicians, so in Canada, we know that Trudeau, does not, give the straight talk. He changes stuff, and he's just, not only bought a pipeline last year, but now he's gonna let him drill in Newfoundland for more oil. So in this graph, for him, you would put his family with his kids and show them going over.
Right, yeah, yeah,
The picture.
yeah, yeah, yeah.
I wanted to come back to the effects. Like I heard already 10 years ago that when all the wheat that we have is coming from North Africa mostly, like the
Russia and Ukraine, most of the wheat.
Russia and Ukraine, but the rest of the Syrians, or I don't know, like there's a lot from the south, but because they get more dry and dry, we will have a shortage of wheat because of lack of water. But yeah, when would that happen? Because clearly, if we don't have any more cereals, I mean, it's
Pretty serious, yeah,
Well,
yeah. So at the rate at which the humanity is,
well, but no, there won't be meat because
That's
meat
what I
are
just
like-
said,
Yeah,
there
yeah,
won't
well,
be
that's
meat,
a
there
good
won't be
cholesterol
fish.
stuff, but,
so at the rate at which we're burning fossil fuels and contributing to the problem, I think the projection is around, in the coming decade, we'll be at that 1.5. And again, there's some, and again, these are all the understandings that we get from the computer models, which are very, very sophisticated. But then the real world steps in and does things that we didn't expect.
no, even quicker.
Yeah,
Mm.
and I had a really nice professor last year also in Palestine, and he was only looking at food, this was his background. And he said, we're a one issue society, so we now chose climate as the one issue. He said, but the real issue is going to be food. And that's going to be before 2030. And people don't even realize
No.
that this is actually going to be. And with this Ukraine thing happening, that was, I think, the first time that I saw it again, sort of on like being broadcasted. Like, well, if there's no grain coming from Ukraine, we don't eat this grain, but the rest of the world does. So then, the problems are going to hit Africa even earlier. So almost
Well,
next
that's
year
right.
already.
Yeah.
Well, it's already now. I mean, the food prices
And
have
that's just,
spiked.
we can't even fathom that because that's not really widely talked about as climate is, for example.
And this year I heard there was a conjunction of three things, like China, because of COVID, retained all the fertilizer.
Yep.
So in French agriculture couldn't buy because it went double, and they didn't have enough. And Russia has the pesticide or something like that, which were blocked also. Or
Yeah, so
yeah,
that
6 months ago it was not blocked, but like potentially people realize that we're not autonomous at all.
Mm.
And I guess with what happening, it will be blocked, and then Ukraine won't be able to. So I think it will come next fall, actually,
Yeah,
or
when
in the fall
they can't
after. I
harvest
don't know.
and everything. Yeah.
So these, I have to say that I can't understand why the focus is only on that.
Yeah.
Not because I'm concerned by food and I like to eat.
Yeah.
It's just
Yeah. Yeah. Yeah.
Yeah,
Yeah.
it might
I mean-
it might speak more to people when it really
Yeah.
touches the food.
Well,
Yeah.
your professor said that, it's about food.
Yeah, but he also said we can't process more than one big issue, no? And
That's
this
it.
is
what we choose.
overarching, also a huge issue. So it's like,
But it's coordinated.
yeah, also,
But
but
I
it's
mean,
also
reposition-
other problems.
Like
Yeah.
reposition climate change as implication monikers, like food insecurity or housing insecurity might be an interesting way to kind of reframe this, right? Because it's,
Migration.
like home security, not like because of violence, but home security because of the environment, food security, child security. That might be a more evocative way to talk about this. Because because it's not accessible, it kind of serves scientists and government in a weird way
Oui, c'est ça. I think
to
so.
not make it accessible.
I think
to
so.
make-
Yeah.
to
It's
not-
intellectual elitism.
I think
Yeah.
so. It's because they're afraid of people's reaction, but at the same time they prevent adaptation.
Yeah. But the
It benefits
difficulty,
them, so that's what it's.
I think what is difficult and what you, I think there's a thing for you also to take is, I'm not sure, but I mean, even of course in science there's still lots of debate.
Mm-hmm.
And it's still sort of, they find out new things and then they say, oh, maybe it wasn't that bad as we first
Mhm.
thought. And so I think you also have to be careful when you frame it, because it can easily be taken as, oh, you're too negative and it's, you know, you're only saying one part of science.
Yeah,
So
yeah,
to be
yeah.
balancing sort of like what do we know and what is sort of agreed upon and what is sort of the unknowns.
Yeah, yeah,
And
yeah.
the food, that's the professor I talked to, he's knowledgeable, but then there might be others who say, no, we have another 10, 20 years we can manage, there's some technical changes happening, and you know, so there is debate still.
Yeah,
But you want to be precautious, you know,
yeah, yeah.
precautionary side, I guess.
Yeah, and all of these big statements about what will happen at this and what will happen
Yeah.
at that are all based on a model, and the models
Yeah.
have got like, you know, variabilities and
Project, no?
yeah, and like in the idea of the bell curve is that, you know, under the main part of the bell curve, most of the evidence suggests that's the answer, but over here there's also, you've got a 5% chance of it being worse,
Yes.
right? But you've also got like a 5% chance of it being not quite as bad.
Yeah.
So, you know, and this is you know, the scientists don't have crystal balls, they just have models.
Yeah.
And if the models are good and they can continue to update on the basis of the information of what the real world is doing, then but overall, it's if you want to know, does my bum look good in this, or do I look good in this, or should I have chicken or fish on the airplane? These aren't questions of science, right? But if you want to understand how the Earth system works, you go to science for that.
Yeah.
Guy, I've got this vision, like this graphic, not graphic, what's a GIF in my head, of every fraction of a degree on the world. It shows just the displacement of people and migration. Because in the UK, immigration and all the right wing and the idiots,
Oh, yeah.
but Rupert was not overly, he was a little bit, he wasn't on board with that one, and I don't understand why. We need to probably ask him that question again. But to me, COVID's been nothing compared to the billions of people that were displaced by climate change over time. So to me, it's like, oh, now I've got to share my street with another 100,000 people.
Yeah.
I
That's
think
it.
this graphic exists.
Is it?
I think Rupert might know it because I remember Jonathan Ekstrom mentioned one link once with just going out. So I think that starts to exist.
So imagine how you got the
Drawdown, there's a thing called Project Drawdown.
yeah.
So they looked at all these different factors that are happening on the world and rank ordered them, rank ordered the impacts, and then rank ordered the interventions and what were the impacts and what were all the interventions. And unsurprisingly, at the top of the list of impact is education. Biggest bang for buck on interventions, better education and education women.
Yeah.
So that was some.
I've just got this, you know, when you imagine a person's actions, you drop a pebble in the pond and the ripples go out. Well, now with climate change, imagine reversing that pebble and reversing the ripples. And now you've got migration, you've got food scarcity, you've got and back to the impact on the individual.
Yeah, it's like one. But I'm wondering if he doesn't want to use it because there's a fear of being like right wing politics starting.
No, I but I understand that, but it's like we're going to build a wall, and it's going to happen, and so we need to head off to the past straight away. I don't know what the right approach is, but it's just
I mean, it's kind of part of the dark side of Brexit, right? Like that there was an understanding that we needed to be able to, the British people needed to be able to create a conclave that was being able to be protected. They had this natural boundary that served them for the last 2,000 years of wars against Europe. And we had to re-establish that protection because that island nation is going to be strong with or without global
I think it
stability.
is one of the. I think some of the you had like a top 5 of places to be. No, when it gets really worse, and then the UK is one.
Yeah. Actually, let me speak to that in the context of Brexit. So I was watching a YouTube of a guy called Gwyn Dyer, D-Y-E-R, who's a journalist specialising in foreign policy and security issues. Travels, meets generals, goes to America, meets the generals, finds out what's concerning the generals. And one day he was talking to these generals, and they said, "Have you come across climate change? Is that on your radar?" And he says, "Oh, yeah, broadly. Why?" He said, "Well, we're all talking about it now. We're all talking about it now. It's like a threat multiplier. You know, we're all talking about how to defend our nations under what's coming." So when Gwyn goes back to the UK, he goes and sits down with some of his generals' mates, and he says, "You guys talk about climate change all the time." He says, "All the time." And generals have got this expression, "Fortress Britain." That's the term that they use.
Oh.
Right? So Gwyn Dyle wrote a book called Climate Wars, I think it was called. It came out in 2011. And one of the things he was talking about in his presentation about the book was...
That's 10 years, more than 10
Yeah,
years.
this is a while ago. It was basically talking about Europe having two parts. And one part of Europe was basically the uninhabitable south, right? And the other part was the Nordic, relatively still intact, like a wall running down the middle of Europe. They're saying that, you could bring 1 million Italians into Sweden, right? Or 500,000. They'd probably be able to integrate them. Everyone loves the Italian food, but not 10 million. And the concept, and comes back to your comment about this science paper the French university worked on called the nodes. It's called something or other, nodes of complexity, and it's basically saying that under the pressure of climate change, where is civilization going to last the longest?
Yes. Yeah.
And it identified 5. It sort of ranked countries, right? But the 5 at the top were the top one by far was New Zealand.
Yes.
Okay, and then the UK was actually quite a long way up as well. And it comes back, and part of the reason why is because it's in a latitude band that's not going to get so heavily hammered. For example, if you're near the tropics and it gets 2 degrees hotter, you're already on the edge of survivability. Whereas if it gets hotter in UK, you've got a lot of wriggle room. There's also a large arable area compared to population size. That's important. And the third thing was you've got a moat you can defend.
Yeah, you can defend yourself.
Which is why New Zealand's so great, because it's got a really big moat.
It's a really big moat.
Tassie?
Yeah. Well, Tasmania was also... Australia was on the list, but because of Tasmania.
Yeah.
So mainland Australia written off, Bass Strait separates.
Do you happen to know what the latitude of Britain is? I
Uh,
want to compare it to Canada.
We're not far off.
45.
We're almost at the latitude. Toronto and Bergerac are almost the same latitude.
But Bergerac, I think here, I looked at
We're a little
map
bit-
of
we're a little
Canada,
bit higher here
France
than
doesn't
Toronto.
look good.
You get...
Did you say?
France doesn't look good. There's some pockets that look okay, but most is getting too hot.
Vancouver Island has a moat.
South of France is already
Okay, so that's-
It's
crazy.
already a problem.
People
But-
can't raise vegetables in their
Yeah.
gardens.
And
It's serious.
I think, isn't it so that the guy that they're saying that the Sahara region is gonna shift like upwards? So
Yeah,
southern
yeah.
Europe is
Yeah.
gonna be like
Portugal
more
is
Sahara.
already in
Yeah.
Yeah, with all the
desertic
fires
region.
and drought. And now people in Sicily, they're shifting like their whole agriculture
Yeah.
to like tropical fruits
Yeah.
now
Yeah.
because they can't.
Mm.
I saw that in Greece as well. They were growing
Yeah.
pineapple and tropical
Yeah.
fruits now instead of the.
And that's already now.
In,
And it's
in
gonna.
Italy also,
Yeah.
they realize that they will lose, and in south of France, they know that they will lose all the wine.
Yeah,
the grape.
yeah.
Mm.
They can't sustain it, and then.
Well,
there's
that's a good
fire.
graphic. Just start working on the wine. You
Oh.
get a lot of people.
No, I don't think I'd recover from that.
Work on the
I'd be
wine.
traumatised if I were to start going down that path. I met a guy once, a professor running this research unit at a university, and is talking about food under climate change, and he says avocados, get into
Yeah.
avocados,
Yeah.
really,
Yeah.
really
Yeah.
tolerant. Like the band of the world that is suitable for growing avocados gets bigger and bigger and
Yeah.
bigger all
So-
the time.
My question around food is
Yeah,
this, maybe
that's-
your
that's it.
professor talked about it. So like in Victoria, we have a climate, and that region goes Victoria, Vancouver Island, it goes on to Portland, Oregon, Seattle. We're in the same bioregion. We can grow food all year long. In the winter, you can grow all your greens, and you have your food underground also, root vegetables. So we can grow lots of food all year round.
Thanks for the invite.
Hmm?
Thanks for the invite.
And so I thought, hey, my friends are starting to do that. My friend picks greens every night, cooks them up for the next day. Thought they're safe. But my question is, what are going to be the climate changes that will or will not allow that same
Yeah.
climate to be there? That's my question.
You can find maps on Google about this. I
Yeah,
don't-
yeah,
I
yeah.
don't know.
Okay.
If you Google climate impacts in that region,
Yeah.
there'll be data.
Yeah.
There'll be data.
Okay.
But here's the thing as well, and I just want to make a couple of extra little drills down into the scientific elements. There's a concept in science called equilibrium temperatures. So, for example, hypothetically, if the silly humans let the planet get up to 2 degrees but then immediately brought it back down again, that is very different from letting it stay at 2 degrees. So, for example, if if we got to 1 degree above baseline, where we broadly are now, and we were then able to cap it at that, and it stayed like that, we would still lose the ice caps over time. It's like, if you've got a pot of water on the stove and you put the gas onto it, it doesn't boil straight away, right? So this equilibrium temperature is this idea of holding a temperature for an extended period of time, has a whole bunch of emergent property actions that come out of that.
Yeah, and there's a kind of hysteresis effect as well, because the temperature goes up, and we're causing it to go up, and let's say we start to cause it to no longer go up and try to decrease our impact. The curve still goes up, and it stays up for a long time.
Yeah.
And then it finally starts to come back.
Yeah, if you turn the gas off the stove, the temperature doesn't go off straight away, right? Yeah.
And that's how those negative or positive, whichever they are, loops happen. Once you set them into motion,
Yeah.
we can't stop them.
Yeah, and that's the other point as well, is that the whole point of 2 is that all of a sudden humans aren't the main contributors to the problem anymore, right?
Yeah.
And nature says, okay, you guys didn't know what you're doing, we're taking over, it's going to take 500,000 years for us to cool things down again.
So, the
Thank you, Gaia. I have to go back.
Thank you.
I was thinking about, all of the different lenses, so to speak, whether it's food or housing or migration, whatever, like a big kind of like a jukebox, like a spherical jukebox, and you could spin it, and you could look at different things with different lenses. So you could say, I want the lens of food, you could have a look, and you could drill down on the lens of food, and then you could see it, you could see the examples of like apples as a trajectory of apples. And you have lots of different things, so you could start to pick the things that really turn you on, so that when you look through the lens that makes sense for you, you can get the information back about what the impact on the thing that's important for you is going to be. Yeah. So that way it makes it really kind of dynamic and
Yeah, I like that. And then you turn a dial. What's it look like at 2?
yeah, exactly. And then you
Yeah.
go, you see it like
Yeah. Yeah.
what happens if this happens?
Yeah.
And then you could the last thing is that there's a motivation for scientists not to freak out the public. And I have always a really, really strong aversion to paternalistic behavior. Because first of all, we're not babies. Second of all, if we're adults and we're acting like babies, we gotta wake up. And I understand we need to have some people to hold the pain and the suffering that's gonna occur, but not allowing it to be exposed is not a favor to anyone.
But we sort of know what we need to do anyway.
And I think many climate scientists are coming down from that. I think that the scientists themselves are more like, there's not one of my professors or teachers that said, oh, I really think we can. I mean, many were very skeptical and very much like, but some were had been politicians, and they said it's not going to change. And they've went through that themselves, so it's like I think they felt like we're the callers in the desert, nobody's listening. My supervisor today said, what Greta Thunberg does, it's not so strange, she just says, listen to the scientists. But we're not listening, because many of them have actually been, recently, and not for a long time, because they were in doubt, and can we do this, and there's a lot of communication theory also saying that then people go into doomism, and that counteracts sustainable behaviors. So I think they were really, but that's changed now. I feel that they are much more raising alarm, but they're not being heard by the people in power. Is that true?
Yeah, and the other thing as well is there's been a big debate amongst environmentalists as to whether you should actually tell the truth, which is fucking insane if you ask me. But the point is that if you were to bring somebody in off the street and convince them that you have a truth, right, and then you tell them what we're talking about, casually discussing, right, that's cause for mental health issues, right? And so I think the issue is that yes, we should tell the truth, but we should have the safe space for that. We should have the social safety net so that people can come to terms with it in their own way, that they can grieve like safely, and then they can come back into the conversation.
But I think we've got the opportunity to tell a positive story and change behaviour. So it's great having the lens on of food and do their migration. We can put the rose tinted lens on and go, green energy. This. These all add up to a different outcome. But we're not doing that. We're not connecting all the dots together.
Yeah.
So in the same carousel, you should be able to just then spin. Okay, so now
So
I'm freaked out about food. So what can we do to
boom. Yeah.
here's-
Yeah.
Grow,
Yeah.
grow,
here's
grow.
what we need to do.
But
Yeah.
don't underestimate how much money and effort goes into suppressing all this
No.
alarm. No?
I'm sure.
I got
Because
the
there's people who make money of all this.
I've got a presentation on NFTs and how do we the intrinsic value thing of nature. And I don't know why, but the Marlboro Man keep jumping in my head.
Ah, yeah.
Because fucking smoking is
Yeah,
cool.
yeah. And they keep selling it.
And they keep selling it. You look out the window in France and everybody's smoking.
There's a lot of people don't go there.
In some good news, such that there is in this space, there was a piece of science came out recently. A paper was saying that if all of the nations of the world honoured the pledges that they've made under Paris,
Yeah.
if they'd honoured them,
Yeah.
right, then we would actually
Yeah.
come short
Yeah.
of two, right? If we just keep doing what we're doing, growing the global economy based predominantly on fossil fuels, we're going to 3 or 4, which is hellscape. And that's a really good point as well. Is that we're talking about 2, and we're talking about all the impacts of it, but we know how to fix the mess, right? We fundamentally know how to do it. We know about the transition. The transition to clean energy is highly problematic in many respects. Okay, because a lot of renewable energy technology is not particularly sustainable. Like wind turbines shed microplastics into the environment, and solar panels require huge amounts of area that might otherwise be nature. There's lots of problems, and plus you've got to put all the energy and minerals into actually produce the things, and a lot of that stuff only now have they found a way to make wind turbine blades recyclable, right? But we're on the cusp of figuring that stuff out, right?
Maybe, but I mean, they luckily found that the amount of energy that goes into making all of those so-called renewable systems is oil and gas.
At the moment. But as you get a greater penetration of renewables, then a larger proportion of the energy to make renewables is renewable.
Well, the raw materials are renewable, but all of the energy to create the objects using the resources that may or may not be renewable, that energy is oil.
Presently. Yeah. But at the moment, if you imagine that we're exploiting all of this oil and gas energy, and we're producing millions of motor cars, when if we actually just kept the motor cars running, we don't need to keep producing new ones. We divert that energy to producing the renewables. All of a sudden, you've got a larger fraction of your energy supplies, and eventually, you're going to be producing renewable energy using renewable energy.
So that's a really simple example. If today we stopped making cars on this planet, we would be completely okay.
Yeah.
We don't need to build another car.
Yeah.
We don't have to
For 10
build a
years.
cow.
For 10 years.
And my neighbors just got in a car accident, dented up their car, and the insurance company wrote the entire car off.
Yeah, exactly. So
That benefit.
yeah, there's many, and that's just the technological stuff. Obviously you've got all the behavioural change about people changing the lifestyle so they don't need to drive in a car or travel.
This is it.
You know-
Consumer, we are consumers, and we don't even want to look at that fact.
Yeah. Now, if you start to bring in all of the things that are at play, you start to see, well, here's 2 options. We can all just go off the cliff like lemmings, which is what we're doing today, or we can actually, through all of the collective actions, come up with an alternative society. As, to use the expression, invent a new civilization.
To invent a new identification, like early said, we are consumers. We're consuming the earth. So consumers consume, and that requires extraction, and so we need a new moniker for us.
Yeah.
Because at the end of the day, no matter what, in any scenario you can possibly imagine, we're going to have to reduce our consumption, which means because we're going to have reduced production, that's going to force reduction in consumption. But also, if we want to hit any targets, I feel like it's like personal targets, I'm going to have to reduce my consumptive behavior to have a different kind of behavior that hopefully increases my happiness versus my spend. And that's against the finance system. Right? It's against the market system. It's going to cause a contraction
which will cause lots and lots of people what they perceive as pain.
So then you have to change to instead of the GDP, you change to the national happiness.
Gross national happiness.
But they are there, all these systems, but they're not, it's like, we had it in one class that we talked about how, or many classes actually, but like there's no infrastructure around them. So it's like the whole world is like using this system, and it's like you see in some companies that they change to a different computer system, and that it takes 3 years for them to shift to the. It's like this with the GDP, like it's permeated in all the. So it's like you have to make a new language almost.
And they have all the power.
And they will know it, yeah.
Some good news again on the good news front, such that you can call it with respect to the Ukraine war, is and back to that paper that says if everybody honours their agreements, we could pull it in before 2. Well, Denmark just the other day says we're getting the hell out of fossil fuels, man. We're over this gas.
Yeah.
This is we're off gas by
Yes.
2030.
Yeah.
Right? This is too much trouble.
Yeah.
We're tied to the
We're
hip
off.
to this crazy Russians, right?
Yeah.
Germany the other day, a few weeks
Yeah.
ago, 2 weeks
Yeah.
into the war, says we are fast
Yeah.
tracking our transition away from onto
true,
renewables,
true.
and they put in 220 billion over 5 years or something allocated to the rapid transition. And the first part of that would be just disciplined energy efficiency. Use half as much energy
Yeah.
to get the same output, and then transfer away from your fossils onto renewables. So it might be that this whole 2-degree thing, 5 years from now, it might be, everyone's freaked out about it, but it looks like it might not happen.
No, exactly.
You know,
there have-
maybe there's more.
No.
positive
There
This-
have been times, when people had to reduce their consumption. That
Yeah,
was
of
around
course.
the World War,
Yeah.
say, and they had to do this. There was two things that happened. People did that, and the other thing is that the whole of government approached this. So we've got a guy in Canada. If I had names, I'd tell you. But that's his whole approach, is we have to take this mentality of all of government doing this and then people doing like they did in the war. They have to consume less and they have to do X, Y, and Z because it has to be everybody working together. And his question is, and why aren't governments doing this? Why? We know Trudeau isn't real smart, but why isn't the whole Canadian government
Russian
like
books.
that? Huh?
Russian books.
I
Canada, right? Like we have a small country, it's really rich, we can talk to everyone, it's kind of safe.
Canada, are you talking about? Mhm.
That it could be, all of these things could really become, like, you know, it's not like a gigantic, it's like in the USA, it's like Canada, we've got 30 million people, we can handle it.
If that man can buy a pipeline 1 year and then the next year start drilling, then look at the reverse of that. He doesn't buy a pipeline, there is no more drilling. That's what you're saying. In Canada, they could just bring it right down, but the only people talking about it there is Elizabeth May and the Green Party. They're the only ones that have any sanity. The
Yeah.
rest are still playing politics. So you talk about a new identity.
Yeah, that's
Politics, which party you belong to. That's all they're still doing. That's why they're not working on climate change. They're still in party politics.
And at the heart of the problem really is that we're still getting around 80% of our global energy from fossil fuels, which means that industry is massively powerful.
Yeah.
Massively powerful.
Yeah.
Now that's not obviously in every country. In Denmark,
It is
saying
in
we're getting the
Canada.
hell away from it.
It is in Canada.
It's when those countries that break free of that yoke start to demonstrate that they've got much more abundant economies, that they've got much healthier people because they're not polluting the atmosphere with toxins from exhaust pipes all the time, then all of a sudden the world's really going to wake up to the fact that what a boondoggle it was, you know. How do these
That's
crooks
a
get
good
away with it
point.
for so long, you know?
Koch
Well,
brothers
the
did
way they
say-
got away with it for so long is they built up over 200 years the systems to manipulate our democratic governance systems
Yes. Yeah.
Right?
Yeah.
and
They
pollute
were
the
so
air
powerful
with
with
climate
that.
denial,
Yeah.
you know?
So Standard Oil kind of killing it, Nikola Tesla potentially, right? Like back in
Yeah,
the
long
intervention.
ago.
Long ago.
They used to die. They used to kill them if they were bringing out the electric car. Those
Yeah,
people would be
here's
killed.
alternatives, like trams, there were trams, you know, there was a tram system all over America, electrified trains everywhere, like little, like little, like, you know, they were everywhere, and
Streetcars.
streetcars
Mm.
everywhere, and it was like a really effective system. There was public transport in America. It was cost effective. It was using electricity, not oil, and directly, and they
Bought 'em up.
the entire bought them up and trashed,
Mm.
and they trashed all of these freaking things that were already built.
But that was also probably still when the sort of mainstream idea was that that was okay to do so, because we didn't really understand the consequences of
Some
the
people
burning
did.
of the
Yeah,
forest.
yeah. Yeah.
I think
Maybe it
people,
was pre that sort of warning. Like
Yeah.
everybody smoked in the whenever.
Well, hemp,
It was normal.
they quashed hemp as well.
yeah.
Mm-hmm. That's true. That's true.
So the people who got quashed knew this was absolutely horrific, but the arm that smacked them was so hard and heavy that they just
That
got
they couldn't,
squished.
yeah.
I mean,
Yeah.
if
But
you
nobody
were
was
if
standing
you're
up
like you
for
said,
them.
if you're really on the edge, you
Yeah.
might even get killed, right? Like
Yeah.
it was that
Yeah.
that business
Yeah,
is
true.
was that vicious. Is that
Is
vicious.
still ambitious. Yeah, for sure.
Okay, folks. Thank
Okay.
you.
Okay.
Thank you.
Okay. Thank you. Should I stop it?
Yeah. Thank you.